Welcome, everybody. Tonight we're working on the Unit 2, Part 1 exercises. Remember, there is the assumption that prior to getting into these materials here that you've gone all through all the lecture materials that I've provided and watched the lecture videos in advance of doing this work. All the assignment descriptions are attached in this document here, which I already have up on screen. Our goal is to work through the first 4 and number 6. All right, so let's bring up that first description. I've got Spider all set to go, and actually maybe I should do a little maintenance here. I'm going to kind of like blow away some of the stuff that's sitting inside there. I have a new file already created. What's my first step? You guys remember what I said the first step should be when you start a new file?
File, save as.
Yeah, save as, first task. Thank you, sir. All right, so I'm going to do a save as, and then I have places where I like to store my stuff, right? So I have a system that I use, which is out on my Google Drive, hooked up through Google Drive file stream, by the way. In my Python class folder, I have a folder from this semester, and then I'm going to need a new folder for my Unit 2, Part 1 exercises. So I'm going to put all of them in that same folder. And yes, there's going to be a Unit 2, Part 2 for next week. So I'm going to give this a name that's meaningful. For me, it's going to be exercise 2_1. Right? And then I'm going to click save, and now I'm ready to code. If you wish, you can remove all the comments at the top, or you can drop the programming prompt in here. But let's read the prompt first so we know what we're supposed to do. It says, write a program that displays the dimensions of a letter-sized sheet of paper in millimeters. Now we're given some information here. It says there are 25.4 millimeters per inch. And it says very explicitly, use constants and comments in your program. All right, so let's do that. I'm going to copy this over, and then we'll start to follow the instructions. So I'm going to paste that in the comment area up top here just for handy reference. All right. Now this should be pretty easy, right? Now, from the standpoint of problem solving this, how would we solve this? Just start typing out code. So this, I'm trying to coach you here a little bit, right? You might want to actually think about like what the math is first. All right. 8.5 by 11 are inches. We need to convert to millimeters, and we're told millimeters per inch is 25.4. So could we, and I'm going to bring up my cheat sheet here, pre-write that code. And now I want you to notice, for example, that millimeters per inch is a given amount. So if I went to Google and say, how many millimeters are there in an inch? It should give me that answer. Is that a value that's going to change? There's the first thing that I'm going to ask. And the answer is no. And when we create variables in computer memory, we will often do something like this. And yes, I am copy pasting this in. I'm doing this for efficiency, basically. But normally, if I was going to create a variable, and I'll just call it my var, whatever, I would put in an equal sign. And if I wanted to type in a number, I would 12, something like that. That's me declaring a variable, spot in memory, where I'm going to store the number 12. Later on, I can change my mind and say my var equals 14, right? And to prove that it changes, you can put print statements in between, right? And then I'm going to just copy that one so that you can see that when I change the value of my variable and print it, it does change, right? So what I put in that location, so I put the 12 in, I printed it, there's a 12. I put the 14 in and printed it again, and now it's a 14. Now, in a traditional language, we sometimes have keywords like constant, and then you name a variable, and then you can't change it, right? And then no matter what I do, I wouldn't be able to change the value of that variable, and that concept is called a constant. Interestingly, Python does not support that. We do it conceptually in Python. So what we do in Python is when we have, notice, an implied constant, a value we really don't want to change. We will name it with uppercase letters with the logical words in the constant name, really a variable, separated by underscores. That way, when I look at my code later, I will conceive this to be a constant. In Java or C Sharp, probably the two other primary languages we teach here at Gateway, in those languages, once again, it's not a rule, it's a convention. We put that constant keyword in front of it. We name the variable and its data type, and then we name it uppercase, just like this. And then we know, once again, that it's a constant just by looking at it in the code. So when I see something like that in my code, I'm like, oh, that's a constant. That's not going to change. In truth, you can actually change it. Right? So I'm just putting that out there so you know, but we're calling it a constant. All right. So that was a little example here at the top, right? But they want us to use constants. So given the information I have up here, what pieces of information don't change? Well, go ahead, Pat. If you're gonna say it, say it. You were gonna unmute and say it?
Yeah, I was going to say the width, 8.5 by 11. That's
Right.
constant.
Right. Like you can't take a piece of paper and go to like Dunder Mifflin and say, I want the 8 by 10-inch paper. Well, maybe they could custom cut it for you. Right. But yeah, a piece of paper, at least here in the US, the standard size is 8.5 by 11. So those are constants also, right, in the sense. So here's kind of the approach that I used the last time I solved this is I declared 3 implied constants, right? And I want you to notice, okay, all uppercase because I don't expect these values to change. The other thing I want you to notice is I used decimal places with all of them. Here's the why. If I used whole numbers for the 11, I could get rid of it. When I start to multiply against the millimeters, it might cast incorrectly unless everything is set to floating point. Right. And the other thing I want you to notice, and this is more of a modern naming convention, like when I learned how to code, I might like abbreviate that variable name. In fact, I think the very first language I learned was like BASIC or Pascal or something like that. And you couldn't name variables more than 8 characters. Right. So you had to get really clever with what you name things. And here, the modern convention is be super verbose with your variable names. Don't let people guess what's in there. Have the variable name explain exactly what it is. So width of paper in inches, very descriptive and to the point, right? There's no guessing what that means. Length of paper in inches, and then millimeters per inch. These are values that, at least in principle, should not change. So we'll call them implied constants. So another thing that I always kind of like to reinforce too, right? And I did this in one of the earlier Kahoots, is we talk about this concept of input, processing, and output. These constants are basically our data inputs for the program. This is the information we're feeding in. Now, granted, the user's not typing it, at least not yet, right? They're hard-coded, but they still are data inputs for our program. All right, that's all the information we need to run this program in principle, right? Or at least do the calculations. So now we get to what we call the processing part. And I'm going to mark it for now, and I might do this on some of the exercises just to kind of reinforce the concept. And in this case, the processing is basically do the math. So I'll just annotate it like that. All right. So what is the math? All right. Let's do a little bit of kind of preliminary thinking here. If it's 25.4 millimeters per inch, what calculation do I have to do to convert the inches to millimeters? Anybody can blurt it out if you want, type it in the chat. All right, I know you guys are all racing the answer, but if you're thinking multiply, that's correct, right? So if I do that calculation, I'm also going to need a place to store it. So what I would do is we're looking for the width and the length in millimeters. So I might write variable names. So for example, I might say width in millimeters. Notice verbose description. Notice the camel casing, capital I, capital M. So this is going to be my variable name that's going to hold the calculation that determines the width in millimeters. Now, because the width of the paper is a constant and the conversion millimeters per inch is a constant, I don't have to type, like for example, I could just do this, 8.5 times 11.0. That would be correct, right? But the point here is to start using the names of the named values in the calculations instead. So I would do width of paper in inches. Notice I'm letting the IntelliSense help me. So as soon as it highlighted, I pressed enter to capture it. And I'm going to multiply that with the asterisk against the millimeters per inch. And then guess what? I'm going to do the same thing with the length. So I'm going to call that one length in millimeters. And then of course we'll take the length of the paper in inches and multiply it by the millimeters per inch. So that's the processing. It's just doing the math and then storing it in a variable. And then of course, the last part of a program, so there's input, processing, and output. So next comes the output. I'm going to label it for now. Put a space in there. And that basically means put the results on the screen. Right. I'm going to start with a blank line. Something I like to do in Python. That's just me. You don't have to do that part. And then I argue that you should, in principle, be very verbose with your output, like so the user knows what the heck's going on. Don't leave the user guessing, because what I could do, right, is I could just say, and I'll give you an example, print the one variable within millimeters. Just do that. And then on the next line, I could just say print length in millimeters. I could do that. And in fact, let's run it and see what it gives us. All right, so I'm going to run it. Oh, that's kind of weird. Right, look at that number. That's not pretty. All right, we'll talk about why that happens. Okay, so here's the next question. Is this even right? Yeah, so if you're yeah, that's right. I trust it. And I'm like, you shouldn't, right? Because what if my formulas are wrong? What if my code's wrong?
You have to put it as an integer.
Well, all right, I'm doing this kind of on purpose to take us down a pathway, Pat, and I'll show you what I'm talking about here in a second. So the first thing I'm going to say is you should always take your stuff and multiply it out in a calculator or a spreadsheet. So 215.9 is what I should be getting here.
Also, when you multiply, you should never have more decimal places than like the most decimal places.
In math,
Yeah.
yeah, but not in coding. This is really kind of a weird anomaly. And I'll explain why this is happening. So sometimes you do these calculations and they come out exactly as they should. And sometimes they need a little tweaking. And the reason it happens is because when we're working in a base 10 number system, we have 10 values to work with. How many values does a computer have to work with? 2, 0, and 1. Those are the only numbers available to a computer. So when we do base 10 conversions, all the numbers get converted to base 2, and then they calculate and then convert back to base 10. And this is a known issue with Python, and it's not a flaw, mind you. People work around this, right? And this is basically a value that is incorrectly going back to from binary back to decimal systems, right? And this is pretty normal. So often what we do is we'll end up rounding the value. So the one that's failing is the first one. So we can use the round function, and I'm going to place parentheses around it. And then one of the things that you can do with the round function is you add a comma inside here and the number 1, which tells you to round it to 1 decimal place. So that's going to be our first maneuver, right? And that's to basically cast it back to the right thing. Now, Jack, was it you that said this? Like, for example, I could fix this maybe with like removing the decimal places here. Did you notice that like 8.5 and 25.4, it's not really an option? With 11.0, I could remove it, but that's not the one that was giving me the issue, ironically. Pretty weird, right? First
I
time
was
I
just
saw it,
saying,
I'm
like,
like,
as a sanity check, the in math, the decimal places is the maximum. Like the maximum number of decimal places in the answer is the one that should be in, I mean, and the question is the one that should be in the answer.
yeah, in principle, yes. But here in programming, we have to work with what we're given. And sometimes you need to do this. There's other ways to work around it too, but for right now, we're going to stick with this approach. All right. So now that we're getting the numbers to display correctly, I would say that maybe we need another print statement in here, and then I'm going to demonstrate a different way to kind of put this stuff up on the screen. So for example, I might have a print statement that at least is kind to the users so they know what's going on. Something like that. A standard sheet of 8.5 by 11-inch paper has these dimensions. And then really what I want to say is this amount of millimeters by this amount of millimeters, right? And in Europe, they know this stuff. They have different size paper in Europe, right? But in one print statement, I could do one print statement that would contain all this stuff. So what I'm going to do here is I'm going to leave that first number in there. Following it, I'm going to put in a comma and then some double quotes, and I'm going to say MM like this. And then I'm going to follow it. And I'm sorry for that box popping up, but it just kind of happens in this tool. And then I'm going to paste in the length in millimeters, comma, followed by millimeters in double quotes. And I want you to look at that syntax carefully. So this is going to put one number up on the screen, and then we do a comma. And what this is doing is it's concatenating the number to the string and also inserting a space after it. So the comma here adds a space. Then we'll say MM space X space from the comma, add the next number, space from the comma, millimeters. So when I run this, ultimately, here's my output. So a standard sheet of 11.5-inch paper has these dimensions: 215.9 millimeters by 279.4 millimeters. So what you're seeing here is one way we can take numbers, concatenate them to text, another number, concatenate to text, and create an output that we're controlling. So this is kind of like the brute force output of variables inside of a print statement. Now, if your mind is saying, what's this whole casting thing? I thought like if it was a number, you can't make it text. By virtue of placing something inside of a print statement, part of the print function is it does the conversion for you. And if you throw a function in there, like the round function, it executes the function, converts it to a string, and then the commas will join it. You can also, and I'm not a fan of this approach generally. I think this works. I can use the plus sign technique. So if you're like, come from a different old school language where you concatenate with plus signs, I think this works too. Let me test it, before, yeah. So that doesn't work. So if you learn like C# or Java, that's how you would do it in that language. It doesn't work here. So I'm going to Control Z my way out of that. Control Z is undo, by the way. It does not like that. Didn't give me an error. Did you notice that? Didn't give me an error. I could force it to work actually by putting a string cast function in front of it, but let's just leave this one where it's at. All right. So reinforcing inputs, processing, output, These are comments. These are implied constants with all capital letters. These are variables that hold the results of math. Here's some output statements and a way to format them. Let's run it one more time so we get some nice clean output here. And you can fiddle with this all you want to make the output whatever you want. This is the first exercise, folks. I think we're good for a break right now. What do you think? All right, let's do a 5-minute. All right, it's let's call it 9 o'clock. We'll be back at 9:05. So I'll pause the video here. All right, moving on to the next exercise, which is exercise 2.2. And I'm going to go ahead and do the recommended first action, which is to save as and name it. We were talking very briefly, by the way, during our break here about these side panels. And the question I received was basically like, how do you make the side panels here different sizes? And basically the answer is you grab the dividers and move them around and you can, whichever ones you want. It's also possible to undock the position, right? Or unlock the position and put it in a different spot of the screen, or undock the panel and just pick the whole thing up as a window and put it somewhere else, right? And if I was doing really big projects where I needed that, I might, this is not one of those. Also, we talked about this little upper panel here, which normally is on the help screen, right? So you can use that to kind of get the Python help libraries and stuff. But there's also the variable explorer. And the thing that we noticed is these are all the variables that are running in memory right now and their current values, including the one that I created and destroyed and got rid of, right? And then we talked about the old days of programming where you'd create and have to know how to destroy your variables at the same time. These are helpful little panels. I wouldn't call these critical, but sometimes, if your program's not behaving well and you're wondering what's being stored in a variable, you can look here and see. Right? And you can see the values that you're dealing with. You don't have to guess at it. All right, let's look at the programming prompt for the next one here, which is kind of similar. We're still working with a piece of paper here. And I'm just going to put the description right up here. Let's read it. It says, write a program that computes and displays the perimeter of a letter-sized piece of paper and the length of its diagonal. Okay. Perimeter, no problem, right? Does it say that we have to convert this to millimeters? Nope. No, so we don't have to worry about that stuff. All right. However, are there any implied constants here, like values that shouldn't change? Yes, of course, right? And just to kind of speed things up, I'm just going to copy paste these in here. The width of the paper is 8.5. The height's 11. I want you to notice I'm not making it 11.0. Maybe I'll change that later. We'll see. Let's play with it a little bit, right? So these are constants. All right. If we're going to calculate the perimeter, and I'm just going to put in a comment here, and maybe I should put one here too. Constants that will not change. Thus the uppercase. Just so we know that, right? In truth, you can change them, just remember. So what's the perimeter, folks? How do you describe the perimeter of something? Well, if you're drawing, right, like let's say this is a piece of paper, the perimeter is basically measuring one side, measuring the next side, and the next side. It's going all the way around, right? Piece of cake, right? Because what's the perimeter? Well, I have two sides. Well, one side that's 8.5, and that's done twice, right? So I could basically multiply the width twice. So let's just code that. So I'll say perimeter, right? It's a good variable name, would be 2 times the width. But we also have two lengths, right? So we would add that to 2 times the length, and that would be our perimeter. Do I need to put parentheses around any of these equations or this expression? Will this calculate correctly? So for example, let's test the calculation. So I'm going to kind of reinforce that concept too. So I got one side at 8.5, another side at 8.5, one side at 11, and another side at 11. So I should get 39 for an answer. 39 inches all the way around a piece of paper. Does anybody disagree with that calculation? 17 plus 22, 39. That sounds right. Okay, so that's the output we're looking for. Can we just test that part of it? You know, like before we like worry about the diagonal. Can I just do a print? And let's just print the perimeter and put it on screen and see if that's the number we get. I'll get rid of this goofy little drawing here. Let's just run it. Uh-oh. Did I misspell something? Name length is not defined. Oh yeah, right. Because I used width and height. And you guys are just copying my code, right? Yeah. So I either need to change this to height or change that to length. So let's just change this to height. So I'm going to highlight that and just paste it in. All right, now let's try it again. 39.0. Okay, it agrees. What if I made this 11.0? Still have the same answer. But you notice by the fact of one of the variables being a floating point number, it casts to a floating point number automatically. And that's kind of one of the casting concepts. Of course, we can't change that one from 8.5 because that's what it is, 8.5. This one, we have the option of saying 11.0 or 11, and either one works the same. Okay, so that part's done. All right, well, here's the problem. If we do a square root, and so I'm going to go to a browser right now. Let me find one. So the formula for diagonal of a rectangle. All right, now I'm looking at this equation, right? This is like shades of math and making people like, I don't know, curl up in the fetal position in the corner, freaking out to the mathematics, right? And it's like, don't worry, I'm not testing you on the math, but you know, sometimes math is necessary. And there is a formula for it, and it's based on the Pythagorean theorem, right? And in order to figure out that diagonal, I have to take the square root of the width squared plus the length squared, or the height, whatever, right? We know how to do exponents, right? Right? You can do width star star 2. That's one way to do it. But how do we do square roots? Is there a function for square roots? Now, here's the answer. In Python, there is not a native mathematical function for square root. That exists in the math libraries. So we're going to learn how to do our first import. All right. So up here, I'm going to say import the needed math library to do square roots. Because it doesn't do it natively. I don't have an operator for square roots in Python like I have on a calculator. So to do that, this is the syntax we use, so please copy me verbatim. So we're going to say from math, which means from the math library, we're going to import the square root function, or technically it's a method. Right? So you got to put that up at the top. The math library is a big Python file that contains a lot of Python functions or methods that do very specific mathematical operations.
If you wanted to, you could also take it to the power of 0.5.
You could, but you know what, Jack? I'd like you to experiment with that and tell me if you get the right answer. Could
Just try it. It does work.
Okay, fantastic. Thank you for pointing that out. So we're importing the square root function, and now we're going to write our formula. So we got the perimeter. Let's compute the diagonal. So First, we have to do the calculation. So we can do this a couple of different ways. First of all, with, right, and it's all capital, right? So with, we could go with to the second power, right? Width squared plus height to the second power. So 2 stars like that. Now, if you look at the formula, like in the browser and in the way it's expressed, right? We want this math to happen first, and then we take the square root. Okay. So the square root will get wrapped around the outside of this. We just say SQRT, parenthesis, and then close your parenthesis, and that it will execute. Now, keep in mind, there's a couple alternates to this. So for example, and last time I coded this in class, we experimented with both. So this is an alternate way to do it, because width squared is the same as width times width. So you can do it like this too. And then, Jack, what is your alternate formula? It would basically be like taking this.
Doing the exponent 0.5.
That would work as well, that formula. Just show you all the different approaches. Which one is rightest or wrongest? Hey, you know, here's the answer. If it works, it works. It doesn't really matter. But how many people know that doing an exponent of 0.5 is the square root? And Jack, you know what the answer to that is? Like, you're probably actively learning this right now, so you remember that. But a lot of people don't know that at all. So I'm just putting it out there. Also, I'm trying to demonstrate importing a math library and using a built-in function in that math library and the technique for it. So kind of, you know, learning a bunch of techniques. Ultimately, whatever works is correct. Right. So we could just print the perimeter, print the diagonal, but let's do a combination of different approaches here. I'm going to replace this print statement with this one. So this is the previous technique we used on the last slide or last exercise, right? Some text, concatenate a variable, concatenate some text, right? And if we wanted, we could take the diagonal. And in fact, you know what? Let's take the diagonal and just print it to start with, because we already know the perimeter and what it is, right? So let's just do print diagonal and see what the output is and see what we need to do with it. So I'm just going to run this. Let's see if it even calculates. All right. So the perimeter is 39 inches. That one's fine. The output of the diagonal is 13.9 blah, 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 blah inches. All right. I'm going to say, and this is you got to make a judgment call here. Do I really care about having this answer accurate to like whatever 15 decimal places? It's kind of irrelevant. It's like 13.9, just shy of 14 is really what it is. And 13.9 is like horseshoes and hand grenades, close enough, right? So we might want to just round this number somehow. Now, previous exercise, we used the round function, right? Or was it the one before that? We did that somewhere. I guess it was right here. And we rounded it to 1 decimal place. So that's one approach. You can use a round function to do the rounding. Or we can use one of the formatting commands and the percent operator. So here's what I'm going to do. Is in this statement, I'm going to put a percent sign in front of the diagonal. Then I'm going to compose a string that's going to include that approach of inserting a variable. So this is kind of like the old-fashioned percent operator approach for inserting the information. So in other words, what comes after this percent sign here, this variable name diagonal, will get inserted into this percent sign here. Notice also that the .2f formatting command is here, so that would round it to 2 floating point numbers. That might be excessive actually, but let's just try this technique so you can see that it works. Let's just run it and look at the output. See how that is much cleaner. And I could, if you want, we could change it to that format and run it. And really, maybe this is the best output. Subjective. All right. As we start to move forward, I'm going to also show you that you can take this approach, which I'm not calling this like obsolete now, but it amazes me that in like 3, 4, 5 years that we've switched to what we call the F string approach. So I'm going to show you how to re-engineer this with F string. We're going to take this print statement and drop the letter F in front of it. And then here in the parenthesis position, I'm going to put in a set of curly brackets, and wow, it like double did them. That was kind of weird. And we're going to drop in this variable name here. And we're going to get rid of that percent sign. So like, notice the difference of approach. I don't have to worry about this. Not that it's complicated to do. But now I can drop the variable right into the string of text directly and still apply the formatting command. And in fact, I think the formatting command, if I'm not mistaken, you know, and maybe I should like make myself fail so you guys can see what an error message looks like, but I'm pretty sure that this is the correct syntax here. Let's see if there's any red marks here. What's that all about? All right, let's just try running it and see what happens. Because if I do have an error and it says invalid syntax, and so let's take a look at that really quick. And notice how when you do get an error message, it tries to tell you where it is in the code, and it points right to that spot. And it says right here, that's wrong. What is the correct formatting command then? Does anybody know? Do I move this to the outside? Does anybody want to Google it for me really quick or look at the course homepage, which I think demonstrates it? And paste it in the chat for me. You guys are going to make me do all the work, right? All right. I did do a little brief little table here about it. There's a colon that we need to add into the mix. Notice that? All right, so let's go back and add that colon. Let's get back to Spider. So we would go colon and then the formatting command. Now let's run it. And there you go. Now, in terms of ease of output and readability, it is kind of it's amazing how fast things change. A few years ago when we started teaching this was the way. This is kind of a new thing, and we we're like, yeah, it's not going to catch on. No, it totally caught on and took over within a few years. And now my strong recommendation is that you always use that approach. Unless you have some reason not to, because it's just easier. The other thing is, if I was doing this approach and I wanted to output multiple variables into percent signs, I would have to list them here with commas separating them and then have multiple percent signs, make sure they're in the right order. And you know what? It's easy to screw it up and make mistakes, real frankly. This approach is direct because the variable is it's directly injected. Inside those curly brackets, you can put your variables, your formatting commands, and math and functions inside those curly brackets. But the F string designator needs to be at the beginning of the string in order for it to operate. It's part of the standard Python library and operates automatically. And once again, in other languages, we typically call this string interpolation. And it is favored in a lot of other languages as well. All right, so that was exercise 2. We'll call that one complete. Let's move on to the next one because we're quickly burning through our time here, of course, right? That's pretty normal for us. This is a pretty basic one, and you guys can obviously complete this any way you wish, but let's go ahead. I'm going to copy that, make a new file here in Spider, do my save as. We'll call it exercise 2_3. Zoom it in. We'll drop our programming prompt up here. Write a program that reads a number and displays the square, the cube, and the fourth power. Use the exponent operator only for the fourth power. Right? Piece of cake, don't you think? However, new wrinkle. This right here, I don't know if you guys are picking up on it. It says write a program that reads a number. Your brain should say, from where? Where is it reading from? The library? Your license plate? You know what I'm saying? So we're going to read this in from, yeah, we're going to get an input from the user. Thank you. So we're going to start out here. I'll do some labeling here. Get input from user. So we're going to write a prompt. And since we're going to be capturing something from the user, we need a spot to place that. So I'm going to ask the user to enter a number. So I'm going to create a variable called number. And then here, I'm going to type an input command, and I'm going to say, please enter an integer. And I'll argue, right? Like a lot of people, I'm real frankly, normal people, like, integer, what the heck's that, right? And you could maybe give them the information, a counting number. You know, you could even go further and say example 1, 2, 3, 4, 5, that kind of thing, right? And then I'll make it even more verbose, and I'll say to see its powers, something like that. And then we'll close that. Oh, I never put a double quote here, so it didn't actually close out. So let's put a quote there and a quote there, and then that will capture the number. But what did we learn during our little, I guess, mini lecture is that when a user types something at the keyboard, it's going to come in as text, and I can't do math with it. So after I capture that number, I could do this really goofy maneuver. I could say number equals int number. So in other words, I'll take the number, which is text up here, convert it to an integer with the number or the integer function, and then store it back in the same variable. Then I can do math. All right, cumbersome and 2 lines of code. And we did this in the Kahoot too. We talked about it. What a lot of modern programmers do is just a rule, is they'll do that conversion on the same line that they're doing the capture. So thus eliminating the need for this second statement. So we're capturing the input here. This function will, the inside function will operate first, right? So that one will operate first. Then the outside function will operate and convert it to a number and then store it here. This is really goofy, but I'm just going to do this. I'm not going to print anything and just run it. And so I'm just going to type, I don't know, here. Sorry, typed it in the wrong spot. Typed it in my code, not in the, you got to click in the console to capture it, by the way. 12, and I'm just going to press enter. All right, but up here in my variable explorer, that number is captured. I just want you to see that. Even though I didn't do anything with it, it did come in as a number, and it is an integer. See, so this is kind of the usefulness of the pattern. Real frankly, I very rarely look at it, but if it helps you to understand and know what a value is, great, use it. All right, now let's do the processing, and we'll say here, this part here is input. So input, processing, output. So next comes the processing. And in this case, it's do the math, right? So if we're going to do a square without using an exponent, right, we would just simply do this. Square equals, how do you do that? Well, how about number times number? Right? Same thing as the number squared. And the cube is the number to the third power. So it's number times number times number. And then if we're doing it to the fourth power, then it's going to, this is where they want us to use the exponent to show that we know how to use it, even though we've been using it already. And we'll do it to the fourth power. All right, so that's the math. Does anybody disagree with the math? I think we're all good, right? Yeah, we trust it. All right, next comes displaying the output. And then I'm going to start with, you know, saying display the results, the output, right? So input, processing, output. And I always like to put a blank line at the top. That's just me. Okay, so this is like me kind of also like teaching you guys how to code, but also teaching you how to code wisely, I'm hoping. When you're writing code from scratch like this and you're interacting with the user, let them know what's going on, right? Like how irritating is it when you run a program and you don't know what's happening in the program or what's going on, right? So they just typed in a number. I'm going to be polite. And here's what I'm going to do. I'm going to say, oh, thank you for entering a number. Here are your results. Catch my vibe here on that. You know, let's let them know what's going on. Let's be communicative. So using the old fashioned, and I am copy pasting this in, I'm doing this for the sake of speed. You guys will have to hand code it, of course. Here's the technique where we just use kind of the brute force concatenation of text and variable, right? And notice how I'm being verbose. The square of your number is, the cube of your number is, the fourth power is, and I'm saying it. But what I would challenge you to do here is, instead of using this technique, let's switch these all to F strings. Since we know that's becoming the new standard, you may as well adopt it now. And then inside here, we'll go curly brackets and type in that variable name, and then we can delete this stuff at the end, right? And just get into the habit, folks, of preferring to do it this way. So like if you go on the internet and watch my older videos, you know, I'm basically going to be replacing all of that stuff with this new approach like this. Right. The other thing I'm doing is I'm also telling them that the program's done. That's kind of helpful too. It might be a little excessive in this regard, but you know, I do want to reinforce that concept to communicate with your user as they're inputting and outputting information. All right, let's run the program. Here comes the run. Please enter an integer to see, oh, I see a typo there. To see its powers, not with an A there. So I'm fixing this. We'll fix next run, it'll be perfect. All right, let's put in the number 5. That's a good one to calculate. So the square is 25, the cube is 125, and the fourth power is 625. I know those are all correct. If you're not sure, you should put it in a calculator or spreadsheet or something and test it. Roseanne, you have a question?
Yeah, sorry, this might be a silly question, but if I had in my print statement, like two separate, like I had a float and an integer, would I have to declare like F before the parenthesis and then like break up the statement?
The F string does not care what data
Okay.
type it is.
Okay.
It doesn't, you know, the F does not imply float. The F is just, we're using F string formatting is what that implies. It'll put the content on the screen in whatever format it is. So if I had a floating point number that was very complicated with a lot of decimal places, this would just put all of it on the screen. If that's the question, I think that's the question.
Yeah, you're correct. Okay, so for an F string, it just means that I'm using like text and numbers together in the same statement, or why couldn't I just put print and then use my exclamation points and then put my, write out my display text?
Well, let's look at the different approaches. Like with this first statement here, the square, you could do it the brute force concatenation method with the comma, right? So I'm going to just show you the 3 different approaches. So this is F string. This is comma concatenation.
Okay, I get it.
The other approach that you could use is this one, where you use the % operator and then put the % here.
Okay. Yeah.
All 3 of those would work.
Got you. Okay.
The modern preferred approach is definitely this one.
Okay. Yeah, I'm following you now. Thanks.
Okay, great. All right, so I'm going to Control Z some of those maneuvers here, just get that stuff back to where it was. I have somebody here that's getting a syntax error. And Jared, what kind of syntax error are you getting? I'm not sure if you're micless today. Okay, fantastic. I'm glad you figured it out. What I will say to you guys though, like if you get errors and you can't figure them out, let's put them up on screen and look at them, because like debugging of code is just as helpful as getting it right the first time. In fact, I'm going to argue maybe more helpful, because what do you do when your code's not working and you can't figure out why? You know, it's a matter of reading the debugger output to make it correct. All right, moving on to the next exercise, which is exercise 2.4. And I have the prompt is already captured. So let's go ahead and make a new program. Do a save as, use our naming convention. And then let's zoom in. And then I'm going to paste in our prompt right here. And this is the prompt. It says, write a program that prompts the user for two integers and then prints the sum, the difference, the product, the average, the distance, the max, the min. And then I want you to also catch a little hint there. Python has functions for max and min. And it's except sequence. Oh yeah. Okay. So we'll take a look at how all of those operate. So let's get the capturing of the input first, right? So we have done a little bit of this already, right? So we could kind of copy our prompt from the previous, and it really should get a pair of numbers from the user. And are we wanting integers? Yes, we're being asked to capture integers. So here's my prompts that I've engineered, right? Two variables, one called num1, one called num2. Makes sense, right? I could call them something else if you wish. Two input statements inside of integer conversion statements. Notice, please enter an integer, and then a separate statement, and it's tweaked a little bit so they don't think they're getting the same prompt again. Please enter another integer, right? And then we can move forward. All right. Now we'll do our processing again. And some of this stuff, real frankly, is pretty simplistic, right? The sum is really easy. All right. What if I want to call my variable sum? Oh, wait a second. It's color coding. And you know what? It's color coding the same color as integer and input, which implies what? That it's a reserved word in the language that we cannot use for a variable name. So if you start writing a variable name that you think is unique and it color codes like this, it's not. And I have a little tidbit of it in the lecture stuff where we talk about Python keywords. So Python has, I don't know how many keywords that are core to its language, but you cannot use any of those as variable names. So for example, I can't use the word print for a variable name. I can't use the word input for a variable name. How do you know it's a keyword? Because it color codes. So I can't just say sum. And so I have to like change it somehow. So I could say sum nums or something like that. Okay, so how do we do the sums? Well, that one's like num1 plus num2. Piece of cake, right? What about the difference? Well, I'm going to call it diff. Yeah, I'm abbreviating a little bit. So that's going to be num1 minus num2. Once again, piece of cake. I don't have to even think about it. Then we have the product. All right, well, that's kind of like multiplying, basically, right? So we can call it prod. And you can call it really whatever you want, as long as you know what it is. I would tend to say verbose, and I don't know if product is a keyword or not. I don't think so. Nope, it's not. So I could call it product. And then we have num1 times num2. And then we have the average. I'll just call that AVG. How do you do an average? Well, you add the numbers together and then divide by 2. But wait, I've already added them together. So I can just take that variable name, right? So I don't have to like redo the math. That's already done. And divide by 2. That will give me the average. See how, basic, clever kind of stuff. And if you're wondering, I mean, that's kind of like an alternate way of doing this. This is a comment, by the way. It's not executing. Just so you see what we're doing there. All right, then we get to the distance. Okay, so this distance is a weird concept, and I don't want to like do like a math teachery kind of thing. But when you're on a number line and you're looking for the distance between two numbers, it's basically the difference. Like I'm subtracting one from the other, but I'm looking as the distance as a positive number, right? So whether the number is a negative or a positive number, there's a difference. So I'm really looking for its absolute value. And there is a function for that. So the distance is basically the absolute value of the difference, basically eliminating the negative sign if your subtraction ends up being negative. So that's the distance. Then we're going to use min and max, right? And if I type min here for a variable name, look, at color code's orange, that doesn't work. So what I'm going to do is I'm going to say my min, and I'll have another one called my max, right? And then I'll start setting values here. And what we're going to do is we're going to use functions, and there's a built-in function for minimum numbers where you just basically feed it in a series of values separated by commas. So num1, num2, it'll find the smallest one and capture it. Be mindful of this. The min function, I could feed in like 100,000 numbers and it would find the smallest one. When you do just two, it doesn't really make a lot of sense, but we're just learning how to use the function. But when you have huge lists of numbers, it becomes super powerful very quickly because then you don't have to look, right? Also, very similar is the max function. So I'm going to just copy paste and change a couple letters here. Oops, sorry about that. And that will capture that. So here's all the processing. So sum, difference, product, average, distance, and max and min. Then we're going to start to put the stuff on the screen. My recommended thing is to use f-string for all of this. So we're going to say display to the screen. Basically, AKA output, right? I like to do a blank line personally. Just make it look nice. And then we can just start writing. And this is stuff you don't really need me to coach you on because now we're just putting the variables on the screen, right? And so do as you will and build it. I'll see who can do it faster. If you guys can do it faster than me, and just say sum, and all of these are going to be F strings, right? So I can be really, really silly about this. And this is how my brain thinks, and maybe yours doesn't work this way, but mine does. I'm gonna do a bunch of F strings, so let me create the foundation for it. And then I'll just say sum nums. Difference. And you know what? If you're really trying to make it look good, maybe you put a colon here or something like that. It's probably a good idea. I called that one product. And of course, the variable names down here do have to match up with what's above. I can certainly hear it raining outside now, you guys. At least where I'm sitting. And I guess I don't need that last one. And you know, and once again, you could be more verbose with the output to just let the people know what's going on. Like you entered this number and that number, and here are the blank, and just list them. I'm just going to go ahead and run this here. Let's look at the output. So we have to enter an integer or counting number. So I'm going to use a couple really easy numbers so I know it's working. So I'll use the number 2 and I'll use the number 5. All right. The sum is 7. Difference is -3. Yes, right. 2 minus 5. Yes, correct. Product is 10. The average is 3.5. Sounds right. Distance is 3 or 3 numbers apart. The smallest one is 2 and the biggest one is 5. So it's all working. 2.5, the one that we're not doing is one where we have formatting commands that get you to make it all line up pretty. And if you want to do that, go for it. I'm not super concerned about that. I'm more concerned about like doing the math, the concepts, the F string, which is the string interpolation, and getting all the formulas and functions and stuff working correctly.
Quick question. That
Yes.
should be absolute value for the difference, right? Not what you've done.
Say that one more time. Absolute value for the difference.
Yeah, that should be absolute value because what you've done is you're taking 2 subtracting 5, which is really not correct, is it? Should
It's
be 3.
absolutely correct. No, it is absolutely correct. Because if I take the number 2, which is num1, and subtract 5 from it, you come up with -3.
But that's not the difference.
Right. That's the answer if you're looking for a
That's the
difference.
though. The difference
Distance is a
3.
concept where
Oh.
how far apart are the numbers on the number line? They're 3 numbers apart. It ignores the negative sign. So I can take the difference of 2 numbers, remove the negative sign. That's their distance. It's more apparent if you use a negative number and a positive numbers as your input. But the absolute, yeah, all absolute value does is strike any negative sign. It just turns all numbers
I
positive.
understand it, but that's okay.
I assure you it's correct. All right, let's move on to the last one, folks, because we are running out of time here. I am going to code all the way through this, but we have 2 minutes of class time left. So if you need to go, you can go. But my objective is to get this all finished. So let's look at that last one and code through. That's exercise 2.6. And for exercise 2.6, we're doing this. Let's make a new file. Make sure I copied that. Do a save as here. Name it. Using our convention. Here's our prompt. Write a program that prompts the user for a measurement in meters and then converts it to miles, feet, and inches. Okay, so this requires research. All right, so I'm going to save us the time on the research. And I've researched this in advance. Okay, so first thing I'm going to do is something kind of goofy. But often when you write Python programs, they kind of have a convention for commenting. So like at the top of a program, you often comment in this fashion, right? Tell the people what you're building, right? Notice the double pound sign at the top, and some people will do a double one here. And if you want, you could turn it into full-on ASCII art, make a box, right? But just to tell people what's happening in the program. Now, granted, I have the superfluous comments up here. So if you want, you could even blow those away. There you go. Now, if you did the due diligence and you go out to the internet and you research this, like you can just Google it. How many meters per mile, right? How many meters per foot and how many meters per inch, which all, by the way, are really values that don't change. So we name them like they're constants. And these are the values. And I'm going to be super kind because it's late at night. And so all the people that left early, they don't get this, right? You can just copy paste right out of the chat, folks. See, the benefit of staying in class for a few more minutes. Yay, right? And you could research that, and there might be more decimal values after that, but these are pretty darn close. Next, and yes, I'm doing this in a hurry up fashion, so I'm doing a lot of copy pasting here. We're going to grab the input from the user. I want you to notice this time that we're grabbing the value and converting it to a floating point number. So if they type in 3 meters, it's going to come in as 3.0. Once again, this is for casting purposes, but it's also possible that they might say this is 3.75 meters. They might give me a decimal number. So let's just capture it correctly and convert it to the right format to do the math. So there's our input from the user. From there, we start to do the computations, right? All right, so we're going to calculate miles, feet, and inches. So let's do miles first. So if we know there's X amount of meters per mile, we can use the meters that were input and then divide it by the meters. I'm waiting for my autocomplete to kick in here, meters per mile. And then for feet, the calculation is meters divide by, and guess what that would be? Meters per foot. Now, I'm not pulling these formulas out of midair if you're just wondering that. Where can you get these formulas? Just Google it and just say convert meters to miles or convert meters to feet or something like that. You'll get the formulas online very quickly. Let's do inches. And that one also is going to be meters divided by meters per inch. Right, so that's all of our calculations. Pretty simplistic, really. If you're doubting like the formula thing, I mean, very sincerely, you know, there's the conversions. And you're going to say, wait, that's not right. That's different. Well, yeah, well, you can switch them. You know, you can put the foot here and the meter there. Now notice how that number matches up with the hard-coded ones. And then you can also ask formula to convert meters to feet, just for example. Right. And once again, if you flip these, I think it already said this on the screen, and I'm kind of being superfluous, right? Divide the length value by 3.28, or we're doing it with code, mind you, and we're doing it symbolically, right? What is left is to display the result. So what we're going to do here is we're going to write a series of print statements. I always like to start with a blank if I can. So we'll do a print, and we'll do F string on all of these. And then once again, I'm just going to save a little time here, get 3 statements ready to go. And then what am I going to display? How about whatever number they typed in? So I'll say, if I typed in 50 meters, I want the display to say 50 meters is this many miles. 50 meters is this many feet. 50 meters is this many inches. And let's pick a rounding point. Let's just go with 2 decimal places. I think that's enough. Okay. So here it comes. So here I'm going to put in the first set of curly brackets meters. And I want each one of my statements to start with that. So I'm going to paste it 3 times. Save myself a little bit of hassle here. And then I'm going to say meters in text. So 50 meters, for example, is, and then I'm going to put in the first one, miles, right? And then we want it formatted. So I'm going to do dot to F. And then close that curly bracket. And then append to the end of it, miles. Right. And then just to save myself a little bit of typing, actually a whole lot of typing, I'm just going to paste these and then tweak all of them. So I'm going to change miles to feet. Oops. And then notice the copy pasting, right? We're smarter, not harder. Here's the reformatted statements. And just for the sake of example, here's the percent operator approach as well. And if you did it this way, I'd be fine with it. I'm totally accepting of it. But I would prefer that you do it this way. So in fact, what I'm going to do here, and then I'm missing a parentheses there, is I'm just going to comment this out. Oh, that's not how we do it here, is it? Too many languages, folks. It's like the triple, there we go. Triple double quotes works. We'll just call that an alternate approach. All right, let's run it. Okay, we're gonna enter a length in meters. Give me a length in meters. I don't know, 456, 4,567. So that's 2.84 miles, 14,983.6 feet, and 179,803.15 inches, by the way, right? How do I know that's correct? I could take these values, right? So I could take this value, and I did show you like that, like Google search thing that we did, right? So I should probably grab the one that says feet. Okay. In fact, I could take the solved version, come up here, paste that in here, and it does the conversion. And notice, you know, it's really, really close. There is some truncating going on because of our formatting, but it's proof that the formula works. And once again, whenever you do calculations, you have to have a way to validate that information. Now, when we're doing inches, feet, and meters, the precision that we're using with 2 decimal places is really adequate. If I was trying to land a man on the moon, these extra digits might put him on Mars. You know what I'm saying? So the precision is relative to the task, you know? Hey, it's a quarter of an inch off is a whole lot different than we missed it by 5 million miles, you know? So just keep those kind of things in mind. I think that's kind of humorous, but that does complete all of our exercises here for tonight. And for any of you that need any extra help, I am going to stop the video and then just stick around and I'll help you, and then we'll call it a night. Otherwise, thank you guys for all sticking around, and I'll see you next time. So this video ends here.